Okay, so yesterday we reviewed log functions. Today we're going to look at finding the derivative of log functions. So we're going to start with the derivative of natural logs. Right, so the derivative of natural log of any function is equal to the derivative of that function divided by that function. So let's differentiate y equals the natural log of x cubed plus 1. We know that the derivative in terms of x of natural log of g of x is equal to g prime of x divided by g of x. And so, if I'm looking at the natural log of x cubed plus 1, then I know that g of x is what's inside my natural log, so g of x is equal to x cubed plus 1. So the first thing I need to find is my derivative of g of x. So what's the derivative of x cubed plus 1?
3x.
Okay, so just 3x squared. And so if I know then that my function, my derivative, is g prime of x divided by g of x, my g prime of x is 3x squared. And my g of x is x cubed plus 1. So my derivative would be 3x squared divided by x cubed plus 1. That's it. Okay, so let's do the same thing for natural log of sine of x. So I know that sine of x is equal to my g of x. That's going to be my g of x function. And I know that my derivative is g prime of x divided by g of x. So what's the derivative of sine of x? Cosine of x. So I know that my derivative function is cosine of x. So that means that my derivative is cosine of x divided by sine of x. And thinking way back to your trig stuff, don't freak out. Do any of you remember what trig function that is? That simplifies to. It's close to tangent. Nope. Tangent is sine over cosine, so since this is cosine over sine, this is your cotangent function. The second part of what we're going to look at today is looking at the derivative of natural logs that involve absolute value functions. So the derivative of natural log of absolute value of x is just 1 over that x. This also means that the natural log of the absolute value of any function is equal to the derivative of that function divided by that function. Positive derivative of that function. Oh yeah, sorry, that's a plus. So, and then the second part of that is that the integral of 1 over x is equal to the natural log absolute value of x plus c. Example 7 asks us to find f prime of x when f of x is equal to natural log of x. Oh. Okay, so knowing that the derivative of the natural log of any function g of x is equal to the positive g prime of x divided by g of x, let's let x be my g of x function. So then in doing so, g prime of x is equal to 1, and so then the positive g prime of x function is also just 1, because 1 is positive. If you ended up with a negative, you would have to turn it positive. And then g of x is just equal to x, so I know that my f prime of x is equal to 1 divided by my g of x function, and my g of x function was x. So 1 divided by x. Alright, now if I look at example 10, I'm given the integral from 1 to e natural log of x dx. I'm going to let u be natural log of x. So then my derivative of natural log of x is one over x, because just like the derivative, the absolute value of x is 1 over x, the derivative of x is 1 over x. So then if I replace my natural log of x with u, and this is like 1 over x dx, so that would be replaced by du. The only thing I have to change is my upper and lower limits. So I'm plugging in 1 to natural log of x. The natural log of 1 is equal to, this is 0. The natural log of e is equal to 1. So this would be, my new limits are from 0 to 1, u du. Okay, so the integral of u would become this would be like just like if you were integrating an x. What would happen to it then? So if this were like an x value, it would become like x squared over 2, right? When you integrate it? Yes? So integrating u would become u squared over 2. And we're going to evaluate that from 1 to 0. So if I plug in my upper limit, I get 1 squared over 2, minus my lower limit, 0 squared over 2. What's 1 squared over 2? 1 over 2. And 0 squared over 2 is 0, and what's 1/2 minus 0? 1/2. So my integral from 1 to e of the natural log of x over x is actually equal to just 1/2. And last thing we're going to look at is the derivative of any type of log, because we've looked at just natural logs, so now let's look at regular log functions. Okay, so the derivative of log base a of x is equal to 1 over x natural log of a. The derivative of a of x is equal to a of x natural log of a. Okay, so if I look then at example 13, find the derivative of 10 to the x. Using the idea that the derivative in regards to x of a of x is equal to a of x natural log of a. Okay, so then if this is 10 to the x power, then this is a is like equal to 10, right? Because a is in my place where my 10 would be. So knowing that, then the derivative in regards to x of 10 to the x is equal to a of x just stays the same, so 10 to the x times the natural log of my a, which in this case was 10. So my derivative is 10 to the x natural log of 10. So you guys are going to be practicing deriving some log functions. So you're going to work on page 418 to 18.